Circuit theory. Good morning to all. Reciprocity theorem. Reciprocity theorem. Statement: if a source of EMF E or current I located at one point in a network containing linear bilateral network elements produce a current I or a voltage V at a second point in a network is the same sources of EMF E or current I acting at the second point will produce the same current or voltage at the first point. That is the statement of reciprocity theorem. Linear lump passive bilateral network LLB network. Let equilibrium equation of the network of figure A. Figure A and figure B shown in network shown in notes. From this network we find equation R11 I1 plus R12 I2 plus R13 I3 plus etc. plus R1 n In is equal to V1. Sigma drop is equal to rise is equal to V1. R21 I1 plus R22 I2 plus XS plus R2n In is equal to 0. No voltage source. Rn1 I1 is equal to Rn2 I2 plus XS plus Rnn In is equal to 0, where In is the loop current in the nth loop. Solving these equations, we find In value shown in notes. Matrix of R112 V1 and matrix of R112 divided by R112 Rnn. That is In value shown in notes. In is equal to V1 divided by determined value and matrix of R212 Rn to n minus 1 value, and R11 I1 is equal to R1 In is equal to 0, and matrix of Rn I1 plus Rn2 I2 plus Xs plus Rn I1 is equal to V1 shown in notes. I1 is equal to 0 R12 XS R1n 0 R22 XS R2n XS V1 Rn2 XS Rnn divided by matrix of R12 Rnn matrix of fourth equation shown in notes. Kindly shown in notes. Since the bilateral network Rjn belongs to n, therefore equation 4 is equal to second equation. In is equal to I1. That is very important for reciprocity theorem. The current in the nth loop due to voltage V1 in the first loop is equal to the current in the first loop due to the voltage V1 in the nth loop with no excitation in any other loop. Therefore, the reciprocity is established in linear bilateral network. Reciprocity holds good when the excitation is the current source, when response is the voltage. However, is not valid for when both the excitation and response for both voltages and current. This theorem is not applicable to networks having a dependent source. That is very important. Reciprocity theorem is not applicable to networks having a dependent source. Kindly noted. Problem: the circuit shown in figure. First, put mesh. The circuit consists of 10 volt sources and resistance. Put A, B, and C, D points so that the reciprocity hold good in above circuit. Put mesh currents I1, I2, I3. Form mesh matrix. Find I3 value. That is 0.5 ampere. Direction C to D. ICD direction. Reciprocity theorem applied. Source is changed into last mesh. Procedure: same mesh current, opposite direction, same above circuit. First source is changed into last mesh. Put mesh currents I1, I2, I3. Using reciprocity equation, I1 is equal to I1. Source change into last mesh. We find I1 value using mesh matrix. I1 is equal to 0.5 ampere. A to B, IAB direction. Hence, reciprocity theorem is proved.